This is section 4.2, solving quadratic equations by graphing. So right now, if I gave you a quadratic equation like this, you do not know how to solve that algebraically, so we have to solve it graphically. So we're going to start out with some vocab. Pause this at any time to make sure you get all the words written down. Go ahead and talk about them. A quadratic equation is a quadratic function that is set equal to 0. So if I give you a quadratic function, f of x equals x squared plus 2x plus 1, and then I actually set it equal to 0, then that is a quadratic equation. And we have standard form, so that's the same thing as when this was equal to f of x. And then we have, and this is just a dash, it's not a negative. Then we have a vocab word, roots. So that's the solutions to a quadratic equation, or really any equation that's set equal to 0. The answers to it for x are called roots. And then we have 0, and that's the x-intercepts of the graph of a function. So the points for which f of x equals 0. So notice that's the same exact thing as roots. So we have different names for them. We can call them x-intercepts, zeros, or roots. And so anytime you're asked to find the root, 0, or x-intercept, it's all talking about the same thing. So again, this f of x equals 0 just means x is your answer, so any x value that makes the quadratic equal to 0. Again, pause the video to make sure you get this all written down. Okay, so your first example is solve x squared plus 6x plus 8 by graphing. So we need to graph this first. So we learned in the last section that the smartest way to graph these is to first find the center of your parabola, so that's your vertex. So we need negative b over 2a. A is equal to a 1, and b is equal to 6. So let's plug this in. Negative of 6 over 2 times 1, so that's negative 6 over 2, which is negative 3. So that is the x value of your vertex. So let's go ahead and make a table that includes the vertex. So remember, the vertex is at our center. So I'll put that in the middle of our table and do 3 above, 3 below. So we'll do negative 5, negative 4, negative 5, and negative 6, and then 3 above, so negative 2, negative 1, and 0. So we just don't do negative 3 to 3 anymore. So now we just need to plug in these values for x to find the output. So really, we're just solving this right now. We're graphing it with this being f of x. So we're just treating this like it was an equation. We're graphing this equation. So when you plug in negative 6, there's our equation. So you have to use parentheses. Negative 6 squared plus 6 times negative 6 plus 8. That is positive 36 minus 36 plus 8. So negative 6 output is 8. Let's also find our y-intercept real quick. Our y-intercept is when x equals 0, and it's our c value, and our c value is 8. So our y-intercept is 8. So right here, I know that this one is 8, and that makes sense because these 2 points should have symmetry. Now let's do negative 5. So negative 5 squared plus 6 times negative 5 plus 8. So that's positive 25 plus a negative 30. So minus 30 plus 8, which is negative 5 plus 8, and that's 3. So I already know that I'm going to have symmetry, so I'm going to go ahead and put that for negative 1 as well. And I'll prove it works. Negative 1 squared is positive 1. 6 times negative 1 is negative 6. So 1 plus negative 6 is negative 5, and negative 5 plus 8 does give us a 3 again. Now I'm going to plug in, I'm going to go ahead and do negative 2, so I don't have to do 4. So plus, because they should be the same thing, plus 6 times negative 2 plus 8. And so that's positive 4 for negative 2 squared, and then 6 times negative 2 is negative 12 plus 8, and we get negative 8 here plus 8 is equal to 0. So negative 2 and negative 4 both have an output of 0, and now we can find our vertex, y value of our vertex. Negative 3 squared plus 6 times negative 3 plus 8. Negative 3 squared is positive 9, minus 18 plus 8. So this becomes negative 9 plus 8 is negative 1. So your vertex is negative 3, negative 1. So now let's graph these points. First point is negative 3, negative 1, so we're right here. And then we have negative 4, 0, and negative 2, 0. Negative 1, 3, and negative 5, 3. And then 0, 8, and negative 6, 8. You draw your line like that. And then we can also draw our axis of symmetry, which is x equals negative 3. Okay, so we're not done yet. It wasn't just to graph it. We're supposed to solve by graphing. So remember, our original equation here is equal to 0. So we're looking for x value, the output's equal to 0. So we're looking for x-intercepts. So your answers to all quadratic equations, so set equal to 0, the answer to all of them are the x-intercepts. So here we have two nice x-intercepts, and we can see that in the graph and on the table. So negative 4, 0. Remember, we're looking for a y value of 0. So here it is. So your answer is negative 4. Negative 4 will give you 0, and negative 2 will give you 0. So your final answer for this problem is negative 2 and negative 4. So when you plug those back in, we already did it down here, but when you plug those back in, it should make a true statement. When you plug in negative 4 for both x's, and evaluate, you should get 0. When you plug in negative 2 for both x's, evaluate, you should also get 0. So again, your answers to all of these are your x-intercepts. So you're going to graph the function and then identify the x-intercepts. For example 2, we're going to graph using our graphing calculator. So we don't have to do it by hand, but we do need to do a little work before we get started here. So first of all, we need to put the quadratic equation in standard form. So there's two ways you can do this one. So remember, standard form, you just need 0 on one side. So the first way you can do it is subtract 4x from both sides. So you'll get x squared minus 4x equal to 0. And so what we're going to do is use our calculator to graph this, and then our answers are the x-intercepts. The other thing you can do is actually subtract the x squared to both sides. And if you do that, your equation will be 0 equals negative x squared plus 4x. So it doesn't matter what side of the equation has 0 on it. It's the same thing. Now you'll notice that this quadratic opens up and this quadratic opens down. But their answers, their x-intercepts, are going to be the same, and I will show you that. So here is the video for the steps on the calculator. Okay, so on your graphing calculator for this one, you're going to go to your y equals and make sure anything in there is cleared out. And you're going to type in your function. So for the first one, I'm going to do the positive one first. So your x, remember your x button's right here, x, and then squared's here. And then it was minus 4x. Hit enter, and then when you want to graph it, you hit graph. If your window is not the standard window, remember you can go to zoom 6. Zoom, and then you can hit 6 to do Z standard. And then our answers are the x-intercepts. So we can kind of see them here. It looks like 0 and 4, but we need to confirm that. And so we can do that by using the table. So you're going to get to the table, it's right here. It's kind of hard to see, but it's on graph. So you're going to hit second, and then graph, which is table. And then we get a table of values. So we can see that 0 does give us an output of 0, and then 4 also gives us an output of 0. So our x-intercepts are 0 and 4. And we can also see the vertex here. 2, negative 4 is our vertex because that's a point that doesn't repeat, and then we have symmetry outside of that point. So our answers for this equation are x equals 0 and x equals 4. Now if we did it the other way, we had negative x squared, so we have negative you have to use this negative sign. X squared, and then it was plus 4x. And we go to the graph, and we can see that our parabola is opening down now, but our x-intercepts are still at 0 and 4, and we can again confirm that on the table. So 0 gives us 0, and 4 gives us 0. And then our vertex is to positive 4 this time. So it doesn't matter which equation you use. One will open upside down, one will open up. And so we can look at them together on the same graph. Oops. It's supposed to be minus 4x. And we can see that they have the same x-intercepts. So it's just one's the reflection of the other. I suggest you always do the positive one. That'll be easier on you. For example 3, we're going to do the same thing. We're going to solve it on our calculator again. So we need to get this to be equal to 0, and the easiest way to do that here, and it keeps our x squared positive, is to add 12 to both sides. So we have x squared minus 8x plus 12 equal to 0. And so we are actually graphing the function x squared plus 8x plus 12. And not plus 8x, it's actually minus 8x. Back in your calculator, clear out what you have. And then we're going to do x squared minus 8x plus 12. And we're going to go ahead and look at our graph. And I do want you graphing these on your paper. Just use the table that you get from the calculator. So I can see that it looks like 2, 3, 4, 5, 2 and 6 look like my answers. But let's confirm on the table. So second graph. And 2 does give me an output of 0. And 6 does as well. So my x-intercepts are 2 and 6. So the answers to this equation are x equals 2 and x equals 6. So just use this table and make a sketch of the graph. So we can just graph the 0, the 5, 0, negative 3, negative 4. Graph those points. So just so you have the graph in your notes, so you know where your answer was, and circle the x-intercepts. So again, our final answer for this one is x equal to 2 and x equal to 6. And we can confirm those are right by plugging those back in here and making sure we get a true statement. So 2 squared is 4, and then minus 8 times 2 is 16, so 4 minus 16 is negative 12. So x equals 2 works. For 6, 6 squared is 36. 4 times 8 is 48, so it's 36 minus 48, which is negative 12 as well. So they both work. Okay, so this next one, we're going to use our calculator too, but we actually have to come up with this equation. So it says use a quadratic equation to find two real numbers with a sum of 4 and a product of 5. So we need a variable here. So we're going to say let x equal the first number. And we don't want two variables, but we can start out with two variables. We just got to make sure we use substitution so that we only have one. So we can say let y equal the second number. So what do we know about these two numbers? Well, we know that their sum is 4. So we know that x plus y is equal to 4. And then we know their product is 5. So I know that x times y is equal to 5. So now I've got to combine these two requirements into one statement, and I want it to be a quadratic. So I'm going to keep this one, and I'm going to substitute this somehow into this equation. So generally we deal with x's, so let's keep our x. So let's solve this guy for y. To solve that for y, we need to subtract x from both sides. So you get y is equal to 4 minus x. So that's your second number. So if you didn't want to do two variables, you could have known that 4 minus x is your second number, because if x is your first number and they add to 4, you would take that away from 4 to figure out what your second number is. So we know that y is equal to negative 4x, is equal to 4 minus x. So we're going to plug that in for y here. And remember, you have to use parentheses. So it's going to be x times 4 minus x equal to 5. So all I did was plug this in for y into this equation. So now we have an equation that will result in a quadratic as soon as we distribute. So let's distribute. X times 4 is 4x, and then x times negative x is negative x squared, still equal to 5. Let's put this in standard form so that we can graph it. And I like to keep my x squareds positive, so I'm going to go ahead and take all the terms to the right side this time. So I'm going to add x squared to both sides. So I get 4x is equal to, and I'm going to put the x squared first, x squared plus 5, because 5 is positive. And then I'm going to subtract 4x from both sides. So I get 0 is equal to the quadratic term, and then I'm going to put my negative 4x next so that it's in standard form, and then plus 5. So this is my equation, x squared minus 4x plus 5. If you did it the other way, you would have negative x squared plus 4x minus 5 equal to 0. And it doesn't matter which way you do it. I just think that keeping this positive, especially if you're doing it by hand, is easier. So our answer to this problem, two numbers that add to give you 4, so a sum of 4, and multiply to give you 5, the answer to that problem is the answers to this equation. So the two x-intercepts we get from this are the answers to the problem. Calculator y equals, get rid of that, and our equation was x squared minus 4x plus 5. And we're going to graph it. And we're looking for x-intercepts. So it looks to me like it does not even hit the x-axis. So there are no x-intercepts. Let's make sure on the table we're looking for outputs of 0. So if we look at the y values, we're looking for outputs of 0. Those are getting bigger. We get down to 1, that looks like that's our vertex. And they're getting bigger as we go up. So 1 is our vertex, and since it opens up, that's the minimum point. So our smallest value is 1. If we can't find 0 on the y side, we look for a sign change, but there's no sign changes either, which means it really doesn't hit the x-axis at all. So what that tells us about this problem is that it's no solution. So again, go ahead and sketch this graph. So let's plot these points. I'll go ahead and do that here. So 2, 1 is your vertex. Then we have 1, 2, and 3, 2, 4, 5, and 0, 5. And that's enough points. Just show that it doesn't hit the x-axis at all. And so since it doesn't, this one is no solution. So anytime you're just given an equation and it doesn't hit the x-axis, you say no solution. Our problem was asking for two numbers that multiply to give you 5 and add to give you 4. So you're going to say that there's no two numbers that do that. No real numbers will multiply to give you 5 and add to give you 4. Okay, one more on the calculator. So we have negative x squared plus 4x minus 1. We're going to go ahead and put that in the calculator. It says if exact roots cannot be found, state the consecutive integers between which the roots are located. We're going to do that, and then I'll show you on the calculator how to make the calculator find an approximation for you. Okay, so I already have it plugged in the calculator here. So go to graph. And we can see that it is not exact. So that's looks like it's between 0 and 1, and it looks like it's between 3 and 4. So let's confirm on the table. And we have a sign change between negative 1 and 2, so that means that 0 occurred between those 2 points. So yep, we have an x-intercept between 0 and 1. That happens again here because it's 2 to negative 1. There had to be a 0 in between here. So the x-intercept's in between 3 and 4. So this is what we're going to put for our answer. So state the consecutive integers it's between. So we can say between 0 and 1, and then between 3 and 4. Now we know that our x-intercepts are between two whole numbers, and so we want the calculator to actually approximate that. So if we go back to our graph, you're going to go to the calc menu. We've used it before, so you're going to do second and then calc. And we're trying to find a 0, so the x-intercept, so you're going to go to the second choice, 0, hit enter. And this is kind of like what we did when we did intersections. So it's asking you where does it need to look. So we know that the first x-intercept right here is between 0 and 1. So you can drag your cursor, but the easier way to do it is just put the two numbers it's in between. But you have to put the least number first. So we're going to plug in 0 and put enter. So we're saying start looking at 0. And then we want it to stop looking at 1 because we know it's between 0 and 1. So type in 1, hit enter again. And then it will ask you if you want it to guess, and we do. So we're going to hit enter. And then we have our answer. So the 0, y equals 0 when x equals this long decimal. I always want you to round to the nearest hundredth. So we'll put 0.27 for our answer. And then we're going to do those same steps again to find the other one. And remember, this number isn't actually exact either. And when we do x-intercepts algebraically, we will find exact answers. So that's just an approximation. So to find the other one, go back to second calc. And again, number 2. Oops. And then once left bound. So again, you can drag your cursor over here to the left of the point and do it. Or we know it's between 3 and 4. So we can do 3, enter. And then so stop looking at x equal to 4 because I know it's not past there. So hit enter. You want it to guess, so hit enter again. And then your other answer that makes y equals 0 is 3.73. So those are your two answers. So we can write those down. X equals, and again, approximations, 0.27 and 3.73. And you will notice, and this will always happen, these two, just the decimal parts, will either add up to 1 or they'll be the same thing. So this could have been 0.73 as well, or this could have been 0.27. So they either add to 1 or will be the same decimal. Make sure you write down this table. These are the 3 options for answers for quadratics. So the ones we've been dealing with, most of them have had 2 solutions, so they cross the x-axis twice, and it could be upside down. We did have a no solution, where it didn't cross the x-axis at all, and it could have been upside down underneath the x-axis as well. And then the one case we haven't had is where the vertex hits directly on the axis, and that's one real solution. So anytime there's one solution, that solution is the vertex. So take some time to write this down, please. This is one additional example that I'm not going to do, but if you want to, you can. The last example is a story problem. So we've got this bridge, and the deck is 1,053 feet above the river. Suppose a marble is dropped over the railing at a height of 3 feet above that bridge deck. How long will it take the marble to reach the surface of the water, assuming there's no air resistance? Use the formula h of t equals negative 16t squared plus h naught, h sub 0, where t is the time in seconds, and h naught is the initial height above the water in feet. So this seems a lot more complicated than it actually is. So we can draw a picture to help us. So here's your bridge and your water, and you know that this distance here to the top of the bridge deck is 1,053 feet, and you're going to drop a marble from 3 feet above that. So 3 feet above that here, I'm going to say that's 3 feet. That's where you're going to drop the marble. So to use a quadratic to solve this is the quadratic we're going to use. We want to place our axes in a smart place. So the easiest place to do that is right here. So that's our y-axis, and this is our x-axis. So our answers where the marble hits the water is going to be our x-intercept. And so when you drop a marble, even though you think you're dropping it straight down, it's actually has a parabolic shape, so in the shape of a parabola. So it's actually going to come down like this, and this formula will help us find that. And you can think of it as the other half of the parabola is on the other side, but it's in negative time, which doesn't make sense in the real world. So that's why I drew a dashed line. So this point right here is actually the vertex, and we know that that point is 0 because it's on the y-axis. Here, the point is 0, and it's 1,056 because it's 3 feet above the 1,053 feet. So really all you have to do for this problem is plug in for h naught, that's your initial height above the water, and that's 1,056. So we're going to rewrite our equation to be h of t equal to negative 16t squared plus 1,056. So remember, h of t, that's just like y, and t is just like x. So we're actually going to solve this one algebraically. We can do that because there's only one term with a variable in it. All of our other quadratics have had a t squared and like a t. But since this just has t squared, we can solve this algebraically. Now there's nothing to solve yet. We're trying to find the x-intercept, or the 0. So that means when this is equal to 0, so you're going to plug in 0 for h of t. You want to know when the height is 0, which is, in our case, the water. When does it hit the water? So we're going to solve this equation. So think of it like solving with the Pythagorean theorem. You just have the x squared you're going to have to get rid of in the end. So first isolate the term with the x squared. So we need to get rid of the 1,056. So subtract 1,056 from both sides. You get negative 1,056 is equal to negative 16 squared. There we go. Now we need to isolate the t squared. So we're going to divide each side by negative 16. That's positive 66 equals t squared. So we know this is not a nice answer, which is typical for real world. You're never going to always have nice answers. And then we want to finish solving this by taking the square root of each side. Now technically, because you took the square root, there are actually two answers here. So it's plus or minus, and when you do the square root of 66, let's estimate to the nearest hundredth, you get 8.12. So technically the answer to this equation is positive or negative 8.12. But since we're in the real world, we know that the positive one is the only one that makes sense, so we're going to just take the positive one. Now that negative one is actually this point right here, so where it hits the x-axis in negative time as well. But again, that doesn't make sense. So our answer is t equals 8.12. So it takes the marble about 8 seconds to hit the water. So you will have one of those in your homework too, and it's just usually you don't even really have to draw a picture except to get that 1,056, but they will give you a formula. So that's it for section 4.2.